Whether you're trying to drive up to a mine without knocking it over in the minefield challenge, or up to a surface without ramming into it in the grand challenge, being able to move forward until your robot is near an object without actually bumping into it is a very valuable behavior. This forward until near capability is exactly what the ultrasonic rangefinder enables on your robot. In this lesson, you will learn how the ultrasonic rangefinder, or sonar sensor, works. The ultrasonic rangefinder operates on the same physical principle as a bat or submarine sonar. It measures distance with sound. The ultrasonic rangefinder sends out pulses of sound and then waits to hear the echoes off of solid objects in the environment. By measuring how long it takes for the sound to bounce back, the robot can calculate the distance the sound traveled and, consequently, how far the object was that reflected it. The sensor is capable of providing that distance in inches, centimeters, or millimeters to the program as its sensor value. One way of using this information in a program is to check whether there are any objects within a certain distance of the robot. This is simply a matter of checking whether the ultrasonic rangefinder's sensor value is less than a certain cutoff, or threshold distance. If an object is closer than the threshold, the robot will do something, like turn to avoid it or stop. The ultrasonic rangefinder is a digital sensor, with two wires labeled input and output. Since it is a digital sensor, the two wires must be plugged into corresponding digital ports on the cortex, with the input wire plugged into the lower port number and the output wire plugged into the higher port number. On our robot model, the input wire is plugged into digital port 8 and the output wire is plugged into digital port 9. Make sure that your ultrasonic rangefinder is correctly configured on your robot before moving on. In this lesson, you learned that the ultrasonic rangefinder measures distance from an object using sound, and how the forward until near behavior will work. Continue on to the next lesson to begin implementing the forward until near behavior.